Good morning, everybody. This is Mukherjee, working as Associate Professor in St. Peter's Engineering College, Hyderabad. And today our topic of discussion is particle in one dimension potential box. So let us see what is this particle in one dimension potential box. So we are going to deal with this called as particle in one dimension potential box. Let us assume an infinite well, but which is defined along only x-axis, x equal to 0, x equals to a, and its potential is along this axis. So this is of infinite length, which is only defined along our x-axis, but y-axis and z-axis we are going to take it as the infinite length. So here we are going to estimate the wave properties of a particle. So what are the wave properties of a particle? Let us take this example like an electron. Let us assume that electron. We know that electron, if at all, if it is in 1s2, like any atom is made up of subshells, like orbitals and subshells like 1s, 2s2, p3, s3, p3, d4, f and so on and so forth. So let us assume that an electron is in one of this shell, 1s, 2s, 3s, whatever it is. So electron in this kind of subshell. So now what is happening is, this electron, let us assume we are going to take this, or we are going to take an analog of this condition as like an electron is in a potential box of this length. So an electron is in this length, in a box of length. And its length is defined along x-axis from x equal to 0 to x equals to a, because the boundaries are only defined along x-axis. So now what is happening? This particle, what is it? This is the particle. This particle is just moving in this, like a wave. The particle is moving like a wave. When it is moving like a wave, what is happening? This particle is going and colliding with this wall. Once again, it will be moving as a wave. It will be colliding this wall. Once again, it will be moving as a wave. Collide with this wall, moving like a wave. Collide with this wall, moving like a wave. Collide with this wall, moving like a wave. It will be undergoing multiple collisions between the walls. So now, when the electron is going and colliding with this wall, this particle has a wave properties which are given by psi. So when this electron is going and colliding with this wall, or when this particle, which is behaving like a wave, is colliding with this wall, what is happening? Assume that this is the particle. When a particle is coming and colliding with this wall, what is happening? It is coming and it is interacting with this wall. For a momentary period of time, this particle comes to rest. And the momentum which is carried by this is given to the wall. But wall is very rigid. It doesn't take it. Once again, it gives back the energy or the motion or the momentum to this particle. So this particle once again takes the energy back. Once again, it moves like a wave. So a wave is moving. And this wave is moving and is coming and interacting with this wall. When it is interacting with this wall, what is happening? It is losing its wave property exactly on this wall. After some period of time, it will be detached from the wall and once again it will be moving like a wave. The same thing is happening here. This particle is going and colliding with this wall. And after some period of time, what is happening? It is once again moving. And when it is moving back, it is once again gaining its wave properties. It is coming and colliding this wall. It is losing its wave properties. It is becoming a particle. Once again, when it is detached from this, what is happening? It is once again gaining its wave properties. So here, when this particle is colliding exactly at x equal to 0, the wave properties are 0. Similarly, at x equals to a, the wave properties are 0. So these are the boundary conditions. So in these boundary conditions, we need to find out what are the wave properties of this electron in this particle in one dimension potential box. So here, x equal to 0 to psi equal to 0, x equal to psi equal to 0. So the boundary conditions are x equals to 0, the wave properties are 0, x equals to a, and wave properties are 0. So what is our equation? The equation is given by dou square psi by dou x square plus 2me by h bar square into psi equal to 0. This is our wave equation. Or for simplicity, I am going to write this as dou square psi by dou x square plus k square psi equal to 0, where k square I am going to represent it as 2me by h bar square. So we are going to take this wave equation, and that wave differential equation is applied to this wave in this particle in one dimension box. And once again, we need to find out what are its amplitude, the wave properties, the energy, and other properties. For that, first of all, we need to find a solution for this, because that's a differential equation of a wave. So we need to find a solution for that wave. So let us assume that the solution for the differential equation is dou square psi by dou x square plus a square psi equal to 0. So let us assume that we need to find a solution for this. Basically in the universe there are only two types of waves. One is it has to be a sine wave, or the other it has to be a cosine wave. So there are only two types of waves. And we already know that the electron which is moving in this well is behaving like a wave. So it has to be either a sine wave or a cosine wave. So first let us assume that the solution is taken as psi equals to a sin kx plus b cos kx. Why are we assuming this? It's very simple. Why are we assuming this? Because we know that the wave is behaving, or if an electron is behaving like a wave, then the wave has to be a sine wave or a cosine wave. And therefore, we are going to take this as the solution assumed as psi equals to a sin kx plus b cos kx. So now let us take the first boundary condition. What is the first boundary condition? X equals to 0, psi equals to 0. So the first boundary condition is x equal to 0 and psi equals to 0. So let us substitute on this. We are going to get 0 equals to a sin k into 0 plus b cos k into 0. So 0 equals to k times of 0 is 0, sin 0 is 0, 0 into a is 0 plus b into k into 0 is 0, cos of 0 is 1, 1 into 1 is b. So 0 equals to b, implies that the b value is 0. So the first boundary condition is trying to eliminate out the b function. So now after first boundary condition, the wave function is given by psi equals to a sin kx. So now let us take the second boundary condition. What is the second boundary condition? The second boundary condition is that x equals to a, psi equals to 0. So let us substitute in this. When you substitute, what is that we are going to get? We are going to get as, the equation is once again given as a psi equals to a sin kx. So when we are going to get this, so what is that we are going to do? We are going to write it as psi equals to a sin kx, and we are going to substitute the boundary conditions which is given by 0 equals to a sin k into a, or this can be written as 0 equals to a sin ka. From here we can have only one value as 0. Either a can be 0 or sin a can be 0. So now if you are going to take a equal to 0, already b equal to 0, we got this as b equal to 0. If now a equal to 0, which implies that there is no wave at all, but already we are assuming that there is a wave, henceforth this a can never be equal to 0, because b is already made 0, so a can never be 0. When a is not equal to 0, the only chance or choice left out is sin ka equal to 0. So now sin ka equal to 0. So when sin ka equal to 0, what is that we need to know? We need to find the general solution of sine. We know that the general solution of sine is given by sin ka equals to sin n pi. So now what is the way we are going to take? We are going to take sin k equal to sin n pi, which implies that k equals to n pi, or k equals to n pi by a. But what is the p? We have assumed that k square equals to 2ma by h bar square, and therefore we have this k value here. We are going to square it up. What is the way we are going to get? K square equals to n square pi square by a square. So we are going to equate these two equations. When we equate these two equations, what is the way we are going to get? 2me by h bar square equals to n square pi square by a square. Or what is the value of h bar? H bar is assumed as h by 2 pi. So substitute this value thus. What is the way we are going to get? 2me by h square by 4 pi square equals to n square pi square by a square. Let us assume this e to be some en. So finally, how are we going to rewrite that equation? The equation can be once again rewritten as (2m en into 4 pi square by h square equals to n square pi square by a square. So pi square and pi square get cancelled out. We are left out with 4 into is 8 8m en by h square equals to n square by a square. Or from this, what is the value of en? The en value is given by en equals to n square h square by 8m a square. This is the energy process. This is the energy process where n is the number of levels. N is the number of levels. That is, that if n equals to taken as 1, this becomes h square by 8m a square. And what is the value of E2? E2 is given as n equals to 2. We get 2 square h square by 8m a square. Or this can be written as 4h square by 8m a square. Or this is nothing but 4 times of E1. Similarly, what is the value of E3? E3 will be 9 times of E1. So this is the energy possessed by the wave of a particle which is behaving like a wave when it is placed in an infinite well of potential V. So this is the equation. So the energy is given by En equals to n square pi square by 8ma square. So now what is the we have assumed? Once again recap the whole thing. The condition is very simple. We have assumed that there is a particle which is behaving like a wave, and this particle is behaving like a wave is placed in this box. When it is placed in a box, it is undergoing multiple collisions between the walls. When it is undergoing multiple collisions, exactly on the wall, when it is undergoing collision with this wall, the wave properties are becoming 0. So this becomes 0. And similarly on this wall, the wave properties are 0. So taking these two as boundary conditions, x equal to 0, psi equal to 0, x equals to s, psi equal to 0. We have done this math so that we got the value as n equals to n square h square by 8ma square. And the wave function is given by psi equals to a sine kx. Very good. So we got the energy. Now we need to find out the amplitude. So let us find the amplitude part for the same equation. Let us take the amplitude part. For this, let us go to complex numbers. The complex number says that z is always represented by x plus iy, or z is also represented by cos theta plus I sin theta. So this is the number whatever we have. So now, if this z equals to cos theta plus sin theta, what is this z complement? This can be written as z cos theta minus I sin theta. So when you are going to multiply this z bar, what is it we are going to get? Cos theta plus I sin theta dot cos theta minus I sin theta. So what are we able to get? We are able to get as a plus b into a minus b. So what are we able to get? Cos theta plus I sin theta, or applying this formula of a plus b into a minus b. A plus b into a minus b formula is always given as a square minus b square. So this can be written as z dot z bar equals to cos square theta plus I square minus I square sin square theta. But we know that I square value is also equals to minus 1. So when you substitute, what is the way going to get? Z bar equals to cos square theta minus of minus 1 into sin square theta. And what is the way going to get? Cos square theta minus x plus cos square theta plus sin square theta is always equals to 1. So z bar is always equals to 1. Similarly, mod z square is also equals to 1. Mod z bar square is also equals to 1. So finally, what is that we have? If you want to take a complex number, the complex number, if it is represented as z equals to cos theta plus I sin theta, its complex conjugate or complement is given by cos theta minus I sin theta. So z bar equals to a plus b into a minus b. We are going to get a square minus b square. Using that formula, we get cos square theta minus I square sin square theta. But when the I square value is equals to minus 1, so this becomes cos square theta minus of minus 1 into sin square theta, which is nothing but r1. Now why should we discuss all these things? Why are we discussing the fundamental properties of complex numbers? Because our wave is also a complex number. Why? Because what is the solution we have assumed? We assume that psi equals to a sin kx plus b cos kx, and this is something similar to our wave. This is something similar to our complex number. Okay. So we need to find out the solution of the amplitude for this equation. So here, what is that we got? Psi equals to a sin kx. This is the solution we got. So we need to find out the amplitude for this. So let us take the amplitude function for this. So to find out what is the way we are going to take, we are going to take triple integral 0 to infinity mod psi star dx dy dz equals to 1. This is one of the properties of this psi. Why? Because what is the physical significance of psi? Psi doesn't have any physical properties, but mod of psi square, which gives an amplitude like current density or charge density or maybe its amplitude. But psi individually doesn't have any much physical representation. That's the reason why we need to convert that complex numbers into the intensity part. For that reason, we are going to take this. Anyway, we are dealing with only one dimension part, so we are going to take it as we are going to take this as integral in place of, because we are going to deal with single integral 0 to infinity mod psi square bar dx dy dz equals to 1, or integral 0 to infinity mod psi square dx, because this is limited to one dimension, so integral dx equals to 1. So this is what we are going to take. But now this dx, we need a boundary condition. What are the boundary conditions? It's defined from x equal to 0 to x equals to a. So this can be written as integral 0 to a mod psi square dx equals to 1. This also represents, what is this one? 1 is the maximum value. What does it mean? It is the maximum probability that we can get. So 1 is the maximum probability. What is that we are trying to find out? What is the intensity? What is the maximum probability of the intensity available here? Once again, what kind of intensity? It can be charge density, it can be current density, it can be density of electrons, or it can also be the amplitude of the wave. So here we are going to take 0 to a mod of psi square dx equals to 1. So let us substitute this psi value here and let us try to evaluate the whole function. Then how do we do it? We know that integral 0 to a sin kx mod square dx equals to 1, or this will be 0 to a square sin square kx dx equals to 1, or this will be a square integral 0 to a into sin square kx equals to 1. So we need to integrate this value. How to integrate this value? Now we need to convert this sin square into another form, because sin square, direct sin square integration is not advisable. So what is the way we are going to do? A square integral 0 to a into sin square can be written as 1 minus cos 2 theta by 2 into tx. In place of theta, what is the we have? Kx. So how can we write this? Sin 2 times of kx. This can be written as a square by 2 integral 0 to a into 1 minus cos 2 kx dx equals to 1. So now we are going to integrate it individually. So a square by 2 0 to a 1 dx minus a square by 2 integral 0 to a cos 2 kx dx equals to 1. Anyway, what is the integration value of 1 dx? It is x. So finally what is the we are going to write? A square by 2 into x within the limits of 0 to a minus a square by 2 into, what is the value of, what is the integration of cos to x? It is sin 2kx. So sin 2kx divided by 2k within the limits of 0 to a equals to 1. So finally what is the way we are going to get? In place of x, substitute this a value. And place of this, we are going to substitute this. What is the way we are going to get? A square by 2 into a minus 0. Here what is the way we are going to get? A square by 2 into sin 2 into, what is the value of k? We have already calculated the value of k. What is it we have calculated the value of k? K equals to n pi by a. So here what is it becomes? 2 n pi by a. In place of x, we are going to put as a minus sin 2 n pi into 0 by a, sorry 2a equals to 1. Anyway, when a get cancelled, 2 and 2 get cancelled, and sin n pi value is always 0. And here 0 into something is 0, 0 by something is also 0, sin of 0 is 0. So this whole expression is equals to 0. So finally what are we going to get? We are going to get as a square by 2 into a equals to 1, or a equals to the capital A, which is nothing but the amplitude. The amplitude is given by a square equals to 2 by a, or a equals to square root of 2 by a. So here we got the amplitude as well as the energy. So with this, we have to conclude this topic here. Thank you.